Good morning. Let's talk about debugging agents at scale. With these autonomous systems, the production challenge isn't just scaling the infrastructure. It's managing the reasoning, the tool calls, all the places in the whole system where something can go wrong. And in these environments, unexpected errors do happen. Today, I'm going to show you how to fix those issues. We will use agent observability and the Cloud Assist investigations agent to dig into a simulation agent error on agent runtime. We will find and isolate the root cause of the error. Then we will deploy a proactive fix, all with natural language. Now, our simulator agent needs to manage a lot of context for the live simulation. To prepare for this, I've added context compaction to that agent. This feature, called Event Compaction in Agent Development Kit, tells our agent to periodically summarize its workflow using Gemini, reducing the total context that's sent to the model at each turn. Now, I deployed this optimization, but we all just saw Richard break the simulation, and I would like to blame him, but Google has a blameless culture, so let's just investigate here. Here in Gmail, I can see the alert firing. The simulator agent is experiencing unusually high latency. Let's click View Incident to open up the cloud monitoring console. OK, so the simulator agent's taking a really long time to run. It's not returning any responses, but it's hard to see exactly why in this view. Let's figure out what's happening under the hood by opening the agent runtime trace view. Now, traces allow us to see the agent's underlying tool calls and reasoning flow. Here I can see that the agent is successfully calling multiple tools, but then it crashed all of a sudden. That's pretty strange. Oh boy, these logs are dense. You know, before I would be panicking, copy-pasting things desperately, but now watch this. I can click one button from the error log and start a Cloud Assist investigation. Gemini Cloud Assist is an AI assistant agent that helps you design, deploy, troubleshoot, and optimize your workloads. Now, this investigation took a few minutes to run, so I've preloaded it here. We can see how Cloud Assist has gathered the logs from the agent and closely examined the agent runtime infrastructure. It looks like the simulator agent is failing to call the Gemini model API due to a request error. Something is wrong with the payloads we're sending to the model. Now, helpfully here, Cloud Assist is pointing to a specific line of our agent simulator code, so let's open that up and keep digging. Now, here's something pretty cool. I can open my IDE, in this case, anti-gravity powered by Gemini 3, and continue the Cloud Assist investigation I had just started in the console. This is because my IDE is hooked up to Cloud Assist through MCP. And Cloud Assist is one of many Google Cloud products with a built-in remote MCP server, ready for all of your AI applications. So from the agent, I've asked, resume the Gemini Cloud Assist investigation about the simulator agent. What is going wrong in agent.py? Now, this prompt takes a minute to run, so I've loaded it here. We can see how the agent is using the findings from Cloud Assist, looking closely at the agent source code. It's even searching GitHub for relevant issues. And look at how the agent synthesized all that information into a clear explanation of what's going on in our code. It seems that the reason we're seeing this 400 error is because we are exceeding the Gemini API's 1 million context token limit. That event compaction that we added to our agent, it is not running often enough to compress the context in between these huge tool calls. Now, here's what I really love about using agents during the debugging process. They don't just find the root cause of the issue. They suggest a proactive code fix to patch the issue. Here, the agent is suggesting that we add a token threshold parameter to our event compaction config so that we are periodically compressing context more often within each invocation. Now, from here, we can approve those changes, view the code diff, and commit this change back up to source control, triggering our CI/CD to redeploy the simulator agent back to agent runtime. That entire process takes about 5 minutes to run, so I pre-deployed it here. I'm back in the agent runtime console, where I've rerun the same query in our patch simulator agent. And we can see that despite exceeding that 1 million context token limit, our simulator is now running without errors, with event compaction running successfully. You know, this whole debugging experience shows that agents like the simulator are still just software. Operating them safely requires transparent metrics, the right debugging tools, and careful attention to scale. And not just infrastructure scale, but things like token scale. Google Cloud uniquely provides a full observability suite for your agents. Cloud Assist and your coding agent don't just identify issues in these systems. They proactively fix the problems that they find. So with the right tools in our belt, operating agents gets a lot easier. Thank you.